In this video, I'm going to work through the review problems for the test on Chapter 5. So let's get started. In the first one, we're finding an indefinite integral. We know it's indefinite because there are no limits of integration on this. So the important thing is to remember your basic rules, and then we have to add the plus c on the end. So when we integrate this, we're going to integrate each piece separately. So we can think about it this way. And then when we integrate, we're going to add 1 to the exponent, divide by the new exponent. Same here, add 1 to the exponent, divide by the new. And then here, this is understood, remember, to be a 7x to the 0. So when we add 1 to the exponent, we now have an x to the first, divided by 1, and then plus c. And then you always want to simplify your answer. 3 over 9 reduces to 1/3. So we have 1/3 x to the 9th minus 7/4 x to the 4th plus 7x plus c. So there is our final answer. And the second one, we're going to have to use algebra to simplify this. So we can rewrite this as 6 over x plus x squared over x dx. So this simplifies to 6 over x dx plus x dx. So I split it up into the two different integrals, and I reduce that second piece, which reduces to x. So now when I integrate, I'm going to have 6 times the ln of the absolute value of x plus x squared over 2 plus c. So there's our final. In this one, to integrate, we're going to have to distribute. So I'm going to use FOIL. So we have 20 minus 5x squared plus 4x cubed minus x to the 5th dx. And I am going to rewrite this, putting it in standard form, so I have decreasing exponents. So we're going to think about integrating each piece separately. So we have minus x to the 6th over 6 plus 4x to the 4th over 4 minus 5x cubed over 3 plus 20x plus c. And then simplifying that final answer, we have negative 1/6 x to the 6th plus x to the 4th minus 5/3 x cubed plus 20x plus c. We have to apply the same concept here. We do have to distribute. So we're going to have 2 square root of t plus, and remember, this is t times the square root of t. So I'm going to write it this way first. And then remember that square root of t is the same thing as a t to the 1/2 power. So when we rewrite this, this is going to be 2t to the 1/2 plus t to the 3/2. This is t times t to the 1/2. And when we multiply and we have the same base, we add the exponents. We need to integrate each piece separately. So we're going to add 1 to the exponent, and then we're going to divide by the new exponent. And then we need to simplify this. Now, dividing by fraction is the same thing as multiplying by the reciprocal. So we could skip straight to this step. And then finally simplify. So there's our final answer. And number 5, we're going to have to split the numerator. Square root is the same thing as a 1/2 power, so I'm going to go ahead and write that. And when we divide and we have the same base, we subtract fractions. So it's the top exponent minus the bottom exponent. 1/2 minus 2 is a -3/2. And I'm going to rewrite 5x squared as 5x to the -2. We can think about integrating each one separately. So I'm going to add 1 to the exponent. -3/2 plus 1 is a -1/2. And I would divide by -1/2, which is the same as multiplying by the reciprocal. I'm going to add 1 to the exponent and divide by the new exponent. And then plus c. So we're going to have -6 x to the -1/2 plus 5x to the -1 plus c. Now I am going to simplify that just a little bit more, make it look nicer. Negative exponents means it needs to be moved. So that square root is going to have to be moved to the denominator. Same thing with the x in the second term. So there's our final answer. Okay, and 6, we're going to have to do a u substitution. We know we're going to have to do a u substitution because this is a composite function, and we don't have a rule for integrating square root of 6x minus 7. We just have a square root of x rule, which is really just our power rule, and we actually kind of use that here when we simplified. So we have a power rule, but we have to figure out how to use it. So let's do our u substitution. U is the inside function. The derivative of the inside would be 6dx. So then we ask ourselves, do we have everything? So there's our u. We are missing the 6 here. We can multiply it in as long as we compensate with a 1/6 somewhere else in the problem. So now we have all of du. Let me label that. So let's do our rewrite. We're going to have 1/6 times the integral of the square root of u du. And now we need to integrate. But before we integrate that, we need to rewrite that as u to the 1/2 power. So we're going to add 1 to the exponent, divide by the new exponent, which is the same as multiplying by the reciprocal. Simplify. This is 2 over 18, u to the 3/2 plus c. And that's the same thing as 1/9 u to the 3/2 plus c. And then since this is an indefinite integral, because there's no limits of integration, we've got to do that back substitution. So there is our final answer. All right, so let's look at 7. So we have to think about what u and du are here. So let's let u be x to the 4th minus 2x cubed. And I would choose that because that's what's being raised to the 5th power here. So that looks like my inside function. The derivative of that would be 4x cubed minus 6x squared dx. And notice that I do have all of my du here. So here's my u. Here's my du. And notice I have all of du in this case, which is great. So let's do a rewrite. So when I rewrite this, I'm going to have u to the 5th times du. And that one's an easy one to integrate. We're going to use that power rule. Add 1 to the exponent, divide by the new exponent. And then make our substitution. So we're going to have 1/6 times our u, which is x to the 4th minus 2x cubed. And that's going to be raised to the 6th plus c. So there's our final answer. Number 8. This is going to require a substitution as well. So our u is our inside function. That's x to the 6th plus 6. Du would be the derivative of that. 6x to the 5th dx. So we have x to the 5th. Okay. So I'm just going to rewrite this. I think it makes it easier to see everything. So here's our u. This is du, but notice we're missing the 6. We can multiply it in as long as I compensate with a 1/6 out here. So we can always multiply numbers in, and what we're doing, remember, is we're multiplying by 1. We're just doing it in a clever way so that we don't change the problem, and that gives us all of du. We can never multiply in variables, just numbers. Rewrite would be 1/6 times the integral of the square root of u du. Now, we have to rewrite that as u to the 1/2 power. And then when we integrate, we're going to add 1 to the exponent, and we're going to divide by the new exponent, and that's the same as multiplying by the reciprocal. Let's do some reducing here. So that's going to be a 1/9 times u to the 3/2 plus c. And then when we substitute back in, we're going to have 1/9 times u, which was x to the 6th plus 6, to the 3/2 plus c. There's our final answer. Okay, let's look at 9. They're asking us to find f of x given a derivative, and notice this point is on f of x. So that corresponds to an x value of 1/2 and a y value of 1. That gives us that initial condition so we can find c. So we have the derivative here, f prime of x. That's going to be equal to 3x to the 5th. And then we're going to integrate both sides. So we're integrating both sides with respect to x. So there's kind of an understood dx here, but I'm just going to multiply it in on both sides. So you can see that when I integrate f of prime of x, I do get the original function. When I integrate the other side, and remember this is a negative exponent because this x to the 5th was in the denominator, so we had to move it up. We're going to add 1 to the exponent and divide by the new exponent. So now we have negative 3/4 x to the 4th. Notice that x to the 4th is in the denominator. Plus c. Now, they have given us enough information to find c. This is called, remember, an initial condition. So let's find c. I'm going to substitute the 1 in. That's my y value. And I'm going to substitute in 1/2 for x. So I have 1 is equal to negative 3/4 times 1/2 to the 4th, and 1/2 to the 4th is 1/16. I'm going to work with that denominator first. 4 times 1/16 is 1/4. When I divide fractions, I keep, change, and flip. So it looks like 13 is going to be equal to our c value. So what's our final answer? Our final answer is f of x equals negative 3 over 4x to the fourth plus 13. Number 10, they're asking us to find the cost function and if the marginal cost function is 10x minus 7, and then we have a fixed cost of 4. So let's talk about the information we have here. So marginal means derivative. So we have a derivative of the cost function. And that's equal to 10x minus 7. Now, if we integrate that, we will get the cost function. So I'm integrating both sides with respect to x. When I integrate the derivative, I get the original function. When I integrate the right, I'm going to have 10x squared over 2 minus 7x plus c. Rewrite. So that's what we have so far, but we've got to use this information. So remember what the fixed costs are. The fixed costs happen when you don't sell anything. What's your cost going to be? And in this case, our cost would be 4 if we don't sell any items. And I'm assuming X represents selling so many items. So we can substitute that information in, and we'll be able to find C. And 4 is going to be C. So our final answer, our cost function, is going to be 5x squared minus 7x plus 4. Okay, let's look at 11. We want to find the integral. Let's do a u substitution again. We don't have a rule for this, so a u substitution is a good place to start. I'm going to let u be that denominator. So the derivative of that would be minus 2 dx. Okay, let's think about what we have. We have this. That's our u. Notice we're missing a negative 2. We can multiply it in as long as we compensate with a negative 1/2 somewhere else in the problem. And now we have all of du. So when we do our rewrite, we're going to have negative 1/2 times the integral of 1 over u du. And that is our ln rule. And then substitute back in. So there's our final answer. Okay, let's look at 12. Now I'm going to think about this one as a rewrite. I'm going to have ln of 8x times 1 over x dx. If you're not sure where to start with a fraction, try pulling the numerator out and kind of undoing that multiplication of fractions there and see if that helps. Let's try letting u be that ln of 8x. So the derivative of that would require the chain rule. The derivative of the ln is 1 over u, so 1 over our argument, times du, which would be the derivative of that argument, which is 8. And we're taking that derivative with respect to x. And notice that reduces to 1 over x dx. And if we do that, we can see that we have everything we need to integrate. We have our u and our du. So when we do our rewrite, we're integrating u du, and integrating that is the power rule. U squared over 2 plus c. So that when we make our substitution, we're going to have 1/2 times the ln of 8x, and that ln is squared plus c. So there's our final answer. Okay, 13 is asking us to identify what kind of rectangles we have here. Are they left, are they right, or are they neither? So we need to look at the interval. So the interval from 0 to 2 is here. Notice that I'm using that right point to identify that rectangle. Okay, that's the point that's touching that curve. The next interval is from 2 to 4. And notice I'm touching the curve at that right point. The next interval is 4 to 6. Again, I'm touching at that right point. And that last interval is 6 to 8. And once again, I'm touching at that right point. So these are right rectangles. 14 is asking us to divide the interval 0, 8 into 4 equal subintervals and draw left rectangles. So let's do that. So I've got to figure out how wide this is going to be. So I need to figure out delta x. Remember, that's b minus a over n. The interval gives us a to b. N is the number of rectangles. So in this case, our number of rectangles is going to be 4. So my interval is going from 0 to 8. And it's going to be 2 units wide. So each rectangle is going to be 2 units wide. And that makes sense based on the picture they gave us here. Because each of those intervals, those tick marks, are 2 units apart. I am drawing left rectangles. So I want to touch the left-hand side. So this first interval is from 0 to 2. Here's the left. And I'm just going to draw that rectangle over. My next rectangle, and I'll do it in a different color so you can see it better. I'm looking at the interval from 2 to 4. 2 is my left-hand point. I go up to the graph and I draw my rectangle. My next interval is from 4 to 6. The left-hand side is at 4. So I go up to the graph, touch it at x equals 4, and then I draw it over. And then that last one goes from 6 to 8. I touch the graph at 6, and then I come all the way over. So that's what my left rectangles would look like. In 15, they are asking us to approximate the area under the graph of the curve using the x-axis and n rectangles. So notice they're giving us L5. That means we are using left rectangles. And we want 5 of them on the interval from 0 to 5. So let's figure out what delta x is. B minus a over n would give us a value of 1. Now, I like to draw a picture of what this graph looks like. This is a transformation of x squared. It is shifted up 2 units. So our graph looks something like this. Just kidding. This is opening up. I don't know why I thought it was opening down. It looks like this. And I'm going from 0 to 5. So when I draw these rectangles, I'm using the left-hand side of each interval. So my first rectangle goes from 0 to 1. I'm going to use the left-hand side. I go up to the curve, touch it on the left, and draw it. Between 1 and 2, I go up to the curve, touch it on the left, and draw it. 2 to 3, I go up, touch it on the left, and draw it. Next interval, touch it on the left, and draw it. And then the last one, touch it on the left, and draw it. You can see our 5 rectangles. Now, I've got to find the area of each rectangle. Each rectangle has a width of 1. So when I look at that first rectangle, I'll call it rectangle 1. The width is 1, but to find the height, I'm going to have to go up to the graph. I've got to figure out what is this height. And that height I can find by using that function. And notice I'm plugging 0 in because that's going to be the height of the graph. I'm touching on that left interval there. Second rectangle, rectangle 2, still has a width of 1. The distance between 1 and 2 is 1. But to figure out the height, how tall is this? It's going to be from here to here. Well, I'm going to use that left point at 1. So I need to find f of 1. The third rectangle has a width of 1. Distance between 2 and 3 is 1. To find the height, I got to use that point here, that left point, which is at 2. Fourth rectangle, width of 1. Distance between 3 and 4 is 1. And I'm going to go up to the graph and figure out what the height is at 3. And then the last rectangle, rectangle 5, still has a width of 1. They're all going to have uniform widths with this method. But I'm going to use that value of 4 to figure out the height. So if we plug 0 into the function, we get 2. If we plug 1 into the function, we get 3. If we plug 2 into the function, f of 2 is going to be 2 squared plus 2. 4 plus 2 is 6. I need to find f of 3. So that's going to be 9 plus 2. And then I need to find f of 4, which is 16 plus 2. So in this step, all I found was what the value of the function was at each of those values. And then we're going to add those together. So I have 2 plus 3 plus 6 plus 11 plus 18. And that gives me 40. So there's my approximated area. Now notice in this case that area would underestimate that curve.